Welcome. Here we go, another one, section 11.1, cells and batteries. We finished chapter 10 talking about static electricity. Now we're going to talk about current electricity in a bit more detail for chapter 11. Here's the homework, learning check for this page, review questions on here. Let me know if you're having trouble with the online textbook. Okay, lots of content to go through with this one. I will be exiting the PowerPoint and going into just into a web browser a little bit. Hopefully that's not too much of a difference. I know maybe if you sort of like the things, but there's plenty of extra info to show you, and a lot of this can be better done with visual. Imagine me talking with my hands a lot because I am, even though I'm sitting by myself in my office. Okay, what is an electric circuit? So it's a closed path along which electrons that are powered by an energy source can flow. Okay, that's it. In the flashlight that you have, a flashlight is just a battery that you put in and then a little bulb, right? There's a little switch, a little clicky thing, right, that you put on, and then it closes the switch and then makes this pathway. The keyword here is closed, and basically electrons just move through a wire of some kind, and then you can do stuff with it, right? An electric circuit requires a source of electrical energy, which is often a cell or a battery. Okay, so you need to get basically you have to get the electrons moving somehow, and you do that with your energy source, right? Okay, let's talk a bit about what these cells are, because cells are within batteries. But let's maybe take a step back and talk about a voltaic cell. There's a picture of it, of an old one here, developed in the 19th century. You know, worked on in the 19th century. Okay, so a voltaic cell, source of energy that generates an electric current by chemical reactions involving two different metals or metal compounds separated by a solution that is a conductor. Okay, a whole bunch of crazy stuff here, but basically you have two pieces of metal, you have some solution that can conduct these things, and then you connect those two metals together, and then what you're going to get is you're going to get electrons flowing through, and you've created a little circuit there. Okay, it's called voltaic. It's so named after Alessandro Volta. He was a scientist, Italian scientist, and he created this voltaic cell by stacking alternating discs of silver and zinc separated by a piece of cloth and salt water. This became known as a voltaic stack. He puts a bunch of silver and zinc with salt water in between, and he found a way that he could create an electric current, that he could generate electricity from this. More specific cells, but I did want to show you one thing. Just a little picture here. This is me literally just searching for circuit. I wrote real because I wanted a real picture. But you know, a battery connected to these light bulbs, right? This is pretty much what a circuit is. And that term circuit, if you think about it like this, electrons go from one side of the battery through the wire in through each of these bulbs and then reconnect to the other battery. Thus, it's closed, right? There's no breaks anywhere in it, and all of these light bulbs can light up because of the energy that the battery is supplying. We're going to talk about this more, but we know that part of how they can do these things like light up is because of the electrons moving through this wire. Okay, so that's what a circuit is. And if I just look up circuit track real quick, we see, right, we see the racetrack here, and this is exactly what I was thinking of, if I have one, anyways. But here's just some like kind of random pictures of like NASCAR or Formula One, right? If you think of car racing, they also race on a thing that's called a circuit, right, or a loop. Thank you, this word. That's, I think, what we want to think about when we are talking about these cells, right? That they are loops and electrons are moving around, and once they've sort of got back to the starting point, they can continue on again, if that makes sense, right? So picture like cars driving around on a racetrack when you picture these cells. That's helpful. It's just a helpful little analogy, okay? The double A or D battery that you put into a flashlight is actually a little voltaic cell. A battery is just a connection of two or more cells, right? You create a battery when you place two or more cells in a flashlight. So what all this is to say is that the batteries that we use commonly, like the double A's or the triple A's or even the D's, all of those batteries that we use are composed of cells. They have these little cells in them that generate electricity. And if you connect a bunch of cells together, you can generate more electricity. or you can have a little bit more energy in it, right? And that's what these batteries are, right? So batteries are just collections of cells inside them, and that's why batteries leak, right? We also mentioned that, oh, hey, there's a solution that's a conductor. We've ever had a battery that's leaked some stuff out? That's because that's the conductor stuff inside that's being leaked out, right? It's very toxic and usually acidic as well. So be careful if you see that, get help cleaning it up, right? So a voltaic cell is made of these things called electrodes and a thing called an electrolyte. The electrodes are those metals, right? We talked about just pieces of metal, right? That's it. They're connected to these things called terminals, right? Just like a start and end point for electrons, if you want to think about them like that, because that's what a terminal is when the electrons stop moving. And then these terminals are made of these different metals. And again, they have different ability to hold on to electrons. So this is very similar to our discussion about static electricity when we talked about our electrostatic series, how some materials had a stronger hold on electrons than others. We see a similar concept showing up here, but now we're talking about electrodes, right? We're talking about electrodes which are conductors. So similar, but different, in case this wasn't challenging enough. Now, this other term, electrolyte, you might have heard this term before, not applying to batteries perhaps, but in our electrical definition, well, in this voltaic cell battery definition, an electrolyte is a conducting solution or paste, right, that conducts electric charge in which the electrodes are immersed in. So basically, what do you need in a battery? What do you need in a voltaic cell? Well, you need electrodes. You need 2 of them. And then you need an electrolyte that can conduct some of that charge. Electrolyte you might have also heard of because it is in power. They are in power drinks, right? Like your Gatorades and your Powerades. Those of you that are into sports or any kind of athletics, you might have to drink these electrolytic drinks, right? Now, it's, I don't know, sort of like, it's kind of similar in how it works in your body than how it works in a battery. You're not generating electricity, obviously, in the same way, at least I hope you're not. And you drink these electrolytes when you've done a big workout because you're going to be sweating a lot of these things out, right? So electrolytes, basically all they are is they're just ions, right? They're just dissolved ions, which we talked about in the chemistry section. So you have ions in your body. When you work out really hard, you sweat them out. So you drink electrolytes to replenish them, right? Because you need them in your body to do different things. I have a picture that's actually coming up. Let's just take a look at it now. We'll have to go back a slide. But we see this is an image of your standard kind of voltaic cell, right? We maybe have aluminum and we have copper. Those are our 2 electrodes. The electrolyte is actually the solution that's all around it. And what are some of the ions in the electrolyte? Well, aluminum ions as well as hydrogen ions, right? Notice how it looks sort of like a battery per se, that if we were to cover up this section, the beaker here, if we covered this up and just put a picture of a battery over top, it would basically work the same way. Electrons go from one of these metals, through a conducting wire, through like a light bulb or something to, the thing you want to power, and then they return through this other wire, and then they go into the other metal, right? And then what ends up happening is we see that the aluminum is degraded, right? It is corroded away because electrons are leaving it. So if electrons leave, it leaves these positively charged aluminum ions that can go into solution. And then on the other end, we see that the electrons can actually have the hydrogen plus, the positive charged ion here, combine to form hydrogen gas, H2. So these electrons are basically supplying and now can create chemical bonds for the hydrogen atoms, and we're basically removing some bonding from the aluminum atoms, right? So there's like basic, you're always kind of, in order to get something out of it, like energy, you need to use something up, right? Similar to how you eat food, right? You have to basically destroy the food, in your body to get the energy out of it, right? It's very similar here. So this is actually being degraded. And hopefully you will notice that, well, this can't last forever because it cannot, right? Because eventually what's going to happen? All the aluminum is going to go away. Once the aluminum is gone, there's no more source of electrons, right? We need to get another piece of aluminum or some other metal in order to complete the circuit again. So hence, when the aluminum runs out, light goes off or the battery is dead. Okay, just going back again, I think this might be a bit easier I want to show you the picture first, and now this slide right here is going to describe more or less what I just said, but just quickly, Right, so it's chemical in nature, that there's chemical reactions occurring. So again, hopefully the chemistry unit will be helpful here. You're using chemical reactions to push electrons in a certain direction to make them do stuff that you want to do. We create ions where the metal is in contact with the electrolyte. The chemical reaction depends on the metal electrodes that are present. So the choice of metal is important here as well. Not necessarily for this level. Just want to point out that it is important, but maybe you don't have to know which metals, right? If you take the grade 11 if you take the grade 12 chemistry, then you will be learning about this in more detail. You talk about voltaic cells in more detail, in which case you will have to pick different metals, okay? So aluminum gives up 3 electrons, making the Al3+, right? Hopefully that sounds familiar. If something is losing 3 electrons, it is losing 3 negative charges, so it will have a positive charge because its protons have not been changed, right? And then those ions go into solution, and then they go into the electrolyte solution, right? And then these ions are what help conduct this the charge. Like I said, it goes away. It limits the life of the cell. The electrons that are released are connected to the copper electrode, which I mentioned before, just so that you can go through it on your own time. Sorry, that was a bit out of order there a bit. Now, maybe while I think of it now, I do have a video. I do have a video that I posted. I put this into my playlist for this lesson. So if you have in the electricity playlist, right? So if you have trouble finding it, but it's a great little like zoom in of what's happening. And so here's zinc. Don't worry about all these things, but zinc ions, right? This is this is the electrode on the left, made of zinc in this case, and then this is like the electrolyte, and these are all sort of electrolyte ions. And we see that all these zinc atoms, right, are going into the electrolyte, and then this light here is the electricity that is traveling from the zinc going through to the other electrode made of copper here, and then you can see that, don't worry about that word there, but then look, copper ions are now attracted to the surface metal and then form back into their atomic state, right? So in this example, we're basically kind of creating more copper on one side. Here's like an actual setup of one. Copper on the one side, you're creating more copper, and then you're using up, in this case, the zinc, right? So we're kind of creating something at one end, and we're destroying something at the other end. On this side, we're creating hydrogen gas, whereas we're using up the aluminum, right? Lots of different types of voltaic cells. What you should be taking away is just I wanted to show you the visual, the up close, because it is kind of hard to picture, but basically if you want to picture them at the atomic level, then that might be helpful for you. Okay, what types of cells do we have? We can classify them by the electrolytes that they contain. A dry cell will contain, as it says, like a solid or a paste type electrolyte that's not fully liquid, right? So those are called dry cells. You have zinc carbon, you have alkaline dry cells, and then basically you have like a positive negative terminal, you have a carbon rod, and then you have the paste, that's the electrolyte. This carbon rod functions, I guess, as both electrodes, whereas sometimes you need 2 different metals, but obviously because of their design, they can be sort of complicated, right? But we see that the paste is the electrolyte in these battery cases. Wet cells have liquid electrolytes, right? Most cells use sulfuric acid as that because it's inexpensive, highly corrosive, and dangerous when it comes in contact with skin. So car batteries they're called lead acid batteries. Car batteries have sulfuric acid in them. Obviously, they're very stable and safe because you're driving around with them. But if a car battery leaks, that is very serious, right? If you get some like AA battery electrolyte on your hand, it is slightly acidic and toxic. But just washing your hand should be enough. Dispose of the battery properly. Whereas the battery in your car, if that thing is leaking, do not touch it. You need someone. You need special equipment, and you need to dispose of it in a special way. So dry and wet are the 2 types, and we also have things that are called primary and secondary cells. Remember that this term cell is referring to the individual like metal electrode electrolytes that are all stacked together, and so we have a bunch of different cells combined when we are talking about batteries, right? A primary cell is something that can only be used once. It cannot be recharged, whereas a secondary cell can be recharged, right? You are all probably too young to know a time when batteries used to just be single use, right? I'm sure that you're not too young, I'm sorry, but like where the majority of batteries were actually single use and no batteries were rechargeable. Whereas obviously a more recent invention in battery technology is making them rechargeable, which is great, right? Because you don't have to, it's not as wasteful, which is nice. So when they're recharged, the electric current is passing the opposite direction, basically reversing it so that it restores it to its full capacity. So we can go back to our analogy here. All the aluminum's gone. It's all in the solution. We have a bunch of hydrogen. If we have this whole thing sealed off, if I were to plug this into the wall, supply it with energy now, right, then I can reverse this chemical reaction. I will take away the hydrogen gas, and I will make more aluminum, right? So I basically just reverse the chemical reaction in this, and that's how your battery is recharged, right? And here's just an example of like a car battery. You can see the solution with all these little cells sort of stacked next to each other, right? So your car battery is a wet cell because it has liquid electrolyte, and it is also a secondary cell because your car battery can be recharged. Your battery is actually constantly being recharged by a thing in your engine called an alternator. So basically what happens is like as you're burning gas, right? And like the gas is what moves your car, but getting the spark going is your engine electricity, as well as like radio, air conditioner, all those things that you use in your car are electrical. So there's a battery that supplies that power, as well as like a starter battery. But then as the engine is turning, you actually use some of that motion to turn the generator, which actually recharges the battery. So as your car is running, it will be recharging your battery, right? So sometimes to recharge a battery, you see people needing those jumper cables. They get a boost, leave the car running for a little bit to get some charge, and then you can go. And then a little table summarizing a bunch of different types of cells and batteries. We have the name of the battery over here, either primary, secondary, dry, or wet, what it's used for, and then some of the good things and some of the bad things, right? So pro meaning good, con meaning bad, right? Let's focus our attention just here quick on lithium ion. You might have heard of that. You use it, if you haven't heard of it, in your cell phone. Pretty much all modern electronics, laptops as well, use lithium ion batteries. Digital camera, like pretty much all modern electronics use lithium ion batteries. They're obviously secondary because they're rechargeable, and they are dry, right? So they don't use liquid, and they're very, very efficient. They're really great to use because they're compact. Obviously, you can, right, your phones get lighter and lighter, so you don't have to have a whole bunch of batteries in them, which is great. But then we do have some issue just because you think about you don't have to necessarily replace your phone battery every couple months, but you replace your phone every year, every couple of years. And that is across the entire world, right? So you have maybe almost a billion people-ish, I don't know, doing this every couple of years. You have to make new batteries, right? So obviously you can recycle some, but the way modern electronics are designed is recycling is not the key design feature for these things. So you're constantly needing to get more lithium-ion batteries, and that can be intensive for maybe economic and environmental reasons. Okay, that is the first section for chapter 11. There's a bunch more sections, in this one. So so there's more than our typical 3 lessons. So please just kind of keep track of that as we go through. And if you're having any trouble with this stuff, because this is difficult, this is difficult material. Even if we weren't distance learning. So if you have any questions, please email me, or just look up some YouTube videos on outside of this. And then, like I said, I'm here. Send me an email, do something, let me know if you need help. Okay, great. Talk to you soon.